Welcome to another AI pattern recognition deep dive.
Today, we're starting with something that sounds, well, maybe almost mundane, but it's secretly one of the most powerful ways AI is already running things. We're talking about those systems that flag a suspicious credit card purchase.
Fraud detection, AI pattern recognition, FDP, AI, PR.
Exactly. And we're going to show you why the thinking, the architecture behind that is actually the single most important blueprint for how systems are being governed. Across finance, sure, but also health, and really kind of every part of society.
It's so true. I mean, FDP, AI, PR, it's moved way beyond just stopping someone, stealing your card details. Your sources, they define it as the most mature technical implementation of this kind of advanced pattern recognition. It really is the foundational case study for how AI governs big, messy, dynamic systems. So our mission today in this deep dive is really to unpack these sources you've gathered, to properly get our heads around how AI defines fraud in this universal sense. Because it's not just illegal stuff anymore. It's basically any systemic deviation from what's established, what's considered truthful or just, what's expected, the norm. And we need to look at what happens when you apply that relentless hunt for pattern fidelity, that drive for conformity to our economies, our politics, even our own bodies.
Yeah, and we've got an incredible stack of sources here. I mean, they really go from the deep tech stuff, graph neural networks, explainable AI, right into these really thorny ethical questions about bias and algorithms. They trace how we're kind of co-evolving with these AI systems that are increasingly overseeing us.
Okay, let's unpack this.
Right. So if FDP AI PR is the blueprint, we have to start with the basics. What makes it actually work so well? It seems to come down to this combination of like incredible precision and just blinding speed.
That's it. The whole system is built on, well, primarily two core technical mechanisms. The first one, as you said, it's foundational. Anomaly detection. This is the mathematical part of it. It's about identifying any data point, or maybe a group of points, that just deviates significantly from what the AI has learned is baseline behavior.
So the AI learns normal.
Exactly. It learns what normal looks like across maybe millions, even billions of interactions, and then it flags anything that sticks out. The classic example is, your credit card gets used every day in Seattle, then suddenly there's this huge withdrawal attempt in Singapore.
Yeah, obvious anomaly. Location, amount.
Right. But the systems now are just vastly more sophisticated. They're not just spotting fraud. They're isolating errors, system intrusions, simple transaction mistakes, all within these massive, sprawling data lakes that companies have.
But the genius part, I think, is how that anomaly detection gets connected to the second mechanism, risk scoring and adaptive learning. It's not just flagging something weird. It's about figuring out how dangerous that weirdness is, like right now.
Absolutely spot on. The machine learning models, they assign a dynamic risk score. And that's key dynamic. It's not a static label stuck on you forever.
Okay.
It changes based on all these weighted factors in that specific moment, transaction amount, time of day, the vendor's history, your recent activity. I mean, dozens, maybe hundreds of things.
Yeah.
But the real game changer, the thing that makes FDP AI PR so different from older AI is the continuous learning loop.
Ah, right. It doesn't get stale.
Exactly. Traditional AI systems, they often degrade over time as the world changes around them. But these algorithms, they're constantly ingesting real-world feedback, what was actually fraud, what wasn't, and they dynamically adjust their own logic. They change the weighting of those factors.
So if fraudsters switch tactics, say from stealing physical cards to creating fake identities online?
The FDP AI PR system adapts. It learns the new signature of deceit. Its baseline normal shifts to recognize that new threat pattern. That's what keeps the model robust against adversaries who are also constantly evolving. It has to learn.
That sounds incredibly effective for stopping, one person trying to rip someone off. But the really big threats today, financially, politically, they aren't isolated incidents, are they? They're complex, coordinated attacks.
Precisely. And that's where just looking at single data points starts to fail. You need relational analysis. And the tool for that, increasingly, is graph neural networks, or GNNs.
Okay, GNNs. Break that down for us. How does that work?
Well, think about it. Sophisticated crime, like money laundering rings or maybe coordinated disinformation campaigns, they rely on networks. Intricate webs of interaction. GNNs change the whole way the AI looks at the data. Instead of individual points, it conceptualizes everything as this huge, complex graph.
Right, like a social network map, but for everything.
Kind of. Imagine a financial network. The nodes in this graph are the entities, could be bank accounts, specific people, devices like phones or computers, IP addresses, whatever. And the edges are the connections, the relationships, the interactions between those nodes. A money transfer, maybe two accounts sharing the same login device, a sequence of transactions that seem related.
Got it.
By mapping this whole constellation, the AI can analyze the topology of the network. It's not just looking for one bad transaction anymore. It's looking for suspicious patterns of connection. Maybe a cluster of brand new accounts, all interacting in a very dense, very rapid way that just doesn't match normal network behavior.
So let's say you have 50 fake identities created almost at once, and they all start funneling the small amounts of money to the same 3 obscure offshore accounts, and maybe they share a few login devices in a way that's just statistically impossible for real users. The GNN sees that whole structure.
It sees the relational anomaly. That coordinated structure doesn't just see 50 individual flags, it sees one big, interconnected, highly suspicious pattern. And that analytical power is what lets FDP AI/PR nail things like synthetic identity rings, complex money laundering schemes, even state-sponsored cyber attacks with much higher accuracy. And crucially, with far fewer false positives than older, simpler rule-based systems.
Fewer innocent people getting flagged.
Right. And here's the really profound conceptual jump, the reason this matters for universal governance. The universal signature of fraud, or really any kind of systemic failure, is almost always this relational anomaly. It's a configuration of relationships within the network that's statistically improbable or just wrong.
So apply that elsewhere. In health, it's maybe a weird relationship between different biomarkers. In politics, dodgy connections between funding sources and policy decisions.
Exactly. The focus of governance starts to shift. It moves away from the really difficult philosophical job of trying to define and police human intent, which is messy and subjective, and it focuses instead on managing the systemic topology, making sure the network itself, whatever it represents, is healthy and its connections make sense.
That is a huge shift. Governance as network management. It simplifies the problem technically, maybe, but wow, the control implications.
It does. Deep ethical questions there. But moving down from the network view back to the individual level, FDP AI/PR also layers in continuous identity verification.
Okay, like what?
Well, things like device fingerprinting. This is where the system generates a unique digital ID based on the specifics of the device you're using, your operating system version, browser settings, screen resolution, IP address, a whole bunch of technical details.
And that helps how?
It's crucial for security. That unique device ID can spot account takeovers, like if someone logs into your bank account from a device the system has never seen before associated with you, or it flags if one person is using the same device to control, say, 20 different accounts that are supposed to be separate individuals. The device pattern itself becomes an anchor of trust.
Okay, makes sense. But then there's something even more subtle you mentioned. Behavioral biometrics. This isn't just static data, right?
No, this is about the continuous pattern of how you behave when you interact with the system. It's constantly analyzing tiny things.
Right.
Your typing speed and rhythm, the pressure you use on a touch screen, the way you move your mouse, the specific curves and acceleration, or even how you swipe between apps on your phone.
Yeah.
It builds this kind of, well, almost a psychological profile tied to your physical interactions.
Whoa.
So if a fraudster steals your password, maybe they get in initially. But if their typing cadence is totally different from yours, maybe way slower or more erratic, or their mouse movements are jerky where yours are smooth, the system flags that difference. It sees a potential usurpation, maybe even before they try to make a transaction. It's like a real-time, ongoing check. Does this feel like the right person? Based purely on these micro patterns.
That's incredibly fine-grained. And looking at surprising applications, one source mentioned using this pattern matching for something called friendly fraud. What's that?
Yeah, this is where it's not an outside attacker, but actually a legitimate, trusted customer who deviates from the norm, usually in a way that costs the business money.
How does the AI spot that?
It's essentially looking for patterns where a customer seems to be intentionally exploiting the trust in the customer-retailer relationship. The models analyze complex behavioral history.
Like what kind of history?
Maybe a customer has an unusually high rate of returning expensive electronics, or they frequently claim packages never arrived, or they initiate chargebacks really quickly after a purchase. If these actions happen in a sequence or combination that's statistically way out of line compared to typical customer behavior.
The AI flags it as suspicious, even though it's a real customer.
Exactly. It recognizes the pattern of dispute, the potential exploitation of return policies or chargeback systems based entirely on their interaction data over time. It's spotting an internal deviation from the expected pattern of honest engagement.
It really sounds like this system is constantly playing catch-up, though, because the moment FDP AI PR gets good at spotting one pattern of fraud,
The adversary adapts. They know the system's learned that trick.
which creates this perpetual computational conflict, right?
It's the perfect description. It's an ongoing AI arms race. The fraudsters, the attackers, they're not static. They're using increasingly sophisticated tools, sometimes AI-powered tools themselves, to find new ways to beat the system.
So the defense can't just react.
No way. The defense of FDP AI PR has to continuously evolve its pattern recognition. It needs to anticipate. It has to model the evolution of the adversary's tactics, try to predict the next attack pattern, not just block the last one. This is constant computational battle back and forth that really, it never ends.
Okay, so we've established this FDP AI PR system is incredibly good at spotting deviations, managing network health, fighting this arms race. But now we have to talk about taking this hyper-efficient machine and using it to govern aspects of human life, which immediately brings up huge questions, right? Trust, fairness, how do we audit this thing?
Exactly. This is the crucial transition. And to understand it, we first need to get a handle on the AI cognitive mechanism itself. What is it actually doing when it recognizes patterns? At its core, AI excels at discovering the logical structure of things, finding the most efficient configuration.
Whether that's the quickest delivery route or the most accurate risk classification for a person.
Right. It finds the optimal statistical pattern.
Yeah.
And your sources point out that this ability becomes truly powerful, truly autonomous for governance when you combine two specific types of AI.
Which are?
You need systems that can both create and act. So you need generative AI, the kind that's really good at synthesis, creativity, pattern generation, maybe suggesting different policy options.
Like GPT-4 and its cousins.
Exactly. Combined with agentic AI, these are the systems focused on autonomous decision-making, on pursuing defined goals persistently, acting on the world.
So the generative part dreams up the policies, the agentic part picks one and runs with it.
Sort of. The generative AI might model, say, a dozen potential economic interventions based on current patterns. But the agentic component is the one that might autonomously decide which intervention to implement based on its analysis of real-time data feeds and risk scores, often, potentially, without a human needing to sign off on every single action.
Okay, but that autonomy leads us straight into the biggest ethical minefield for AI governance, the black box problem. These deep learning models, the ones making these complex judgments, we often can't see how they arrived at the answer.
And that's completely unacceptable for governance. If an AI system can take an action with real consequences, freeze your bank account, deny you a loan, flag you for a serious health intervention, maybe even guide law enforcement deployment.
You have a fundamental right to know why.
Absolutely. The rationale must be accessible. If the AI flags you as, say, high risk for defaulting on a loan, you need to understand which factors led to that conclusion. Otherwise, the system can't be audited ethically. You can't contest the decision effectively. You can't fix potential errors in the data or the logic. It becomes unaccountable power.
So that's where explainable AI, XAI, comes in. These are the tools trying to pry open that black box.
Exactly. XAI techniques aim to shed light on the process. They try to show which specific features in the data, which data points, were most influential in leading the AI to identify a particular pattern or make a specific classification. It's about making the reasoning transparent.
But just having an explanation doesn't solve everything, does it? The sources talk about a constraint.
Right. This is a really critical design principle they highlight. Optimality constrained transparency. It acknowledges a fundamental trade-off, meaning we could potentially build an AI model that's, say, 99.99% accurate at predicting fraud. But what if achieving that last tiny fraction of a percent requires such intense computational complexity that the model's reasoning becomes completely opaque, fundamentally uninterpretable, even with XAI tools?
So the constraint says that's not acceptable.
Precisely. That system, even if technically more accurate, fails as a governance tool. We might have to accept slightly lower raw accuracy, maybe 99.8% instead of 99.99%, if that allows the system's reasoning to remain understandable, auditable, and contestable by human standards.
So we deliberately sacrifice a tiny bit of performance for the sake of transparency and accountability.
We must. A governance system that's statistically near perfect but can't explain itself fails the basic test of purpose alignment. Because if you can't understand its logic, you can't ensure it aligns with human values, you can't correct it when it deviates subtly, you can't adapt it based on moral nuances the machine misses. Interpretability has to be prioritized alongside accuracy.
Which makes the whole human-in-the-loop HITL framework absolutely essential. It's not just a nice-to-have safety net. It's structurally required.
Operationally necessary, exactly. Humans remain critical. First, as active learners, especially during the system's training and refinement phases.
What does that work in practice?
Well, imagine a situation where the AI isn't quite sure about a case. Maybe a risk score is right on the borderline. It has low confidence in its judgment. It flags that specific case for a human operator.
Okay.
The human operator then reviews the evidence, the data points the AI considered important, and makes the final call. They might correct the AI's output. And crucially, that correction feeds directly back into the model. The AI learns from the human judgment. This iterative process, human experience refining the statistical engine, is how you improve accuracy and alignment over time.
But this reliance on humans also shines a light on the AI's own conceptual limitation, right? The things it just doesn't get.
That's a really important point from the sources. AI is absolutely brilliant with statistical patterns learned from enormous data sets. Correlation detection is its superpower. But it often struggles with nuanced, human-level concept learning. Things like generalizing from just a few examples, or understanding abstract concepts, or grasping context and causality in the way humans do.
You mean an example?
Okay, an AI can analyze millions of images of traffic lights and learn to recognize red, yellow, green perfectly. But unless it's been explicitly taught the concepts of right and left relative to, say, the direction of travel, it might fail to apply that simple spatial understanding correctly in a novel situation, like an unusually placed temporary traffic light. It understands the pattern of the light color, but maybe not the underlying traffic flow concept. It gets correlation, but often misses causation or contextual meaning.
Which completely reframes the future role for humans working with these systems. We're not just feeding the machine data anymore.
Not at all. We stop being the data processors or the simple exception handlers. The sources argue the future human role shifts dramatically to becoming a pattern auditor.
A pattern auditor, what does that entail?
Our primary job becomes conceptual correction. We focus on ensuring that the AI's incredibly efficient, statistically driven patterns don't drift away from fundamental human concepts, from ethical norms, from common sense reality that the machine, locked in its statistics, cannot perceive. We become the bridge between the math and the meaning. We audit the patterns for conceptual soundness.
And as these AI systems get more autonomous, especially in high-stakes areas like medicine or finance, the need for explicit trust and consent becomes paramount.
Absolutely non-negotiable. For any AI system making autonomous decisions with significant impact on people's lives, the sources are clear. Explicit, informed consent is required, or at the very least, detailed, transparent discussions about how the system works before it's deployed on you.
Like consenting to a medical procedure.
Exactly that level of seriousness. You have the right to understand how the governance system is making decisions about you, what data it's using, what its limitations are. If you don't have that, it's not just opaque. It's potentially an institutional violation of your autonomy.
Okay, here's where, for me, it gets really interesting and maybe a bit scary. We've talked about this pattern-finding machine being super efficient. But what happens when you point that ruthless efficiency at our existing human systems, our economies, our justice systems? The AI isn't just detecting fraud then, it's like holding up this incredibly dangerous mirror to all the flaws and biases already baked into society.
That's a perfect way to put it. Let's start with economic patterns. How does this AI impact wealth distribution? The sources analyze this quite deeply, framing AI's effect as a form of biased technological progress.
Biased technological progress, what does that look like on the ground?
Well, in the short to medium term, what tends to happen is that the productivity gains from AI, the efficiencies it creates, they don't spread out evenly. They tend to concentrate very heavily in the economies, or even the specific companies, that already have the capital, the data, and the technical expertise to adopt AI quickly and effectively.
So the rich get richer, basically.
It structurally reinforces existing advantages. It can exacerbate disparities between countries, potentially reversing decades of global convergence where poorer economies were catching up. And it can worsen inequality within countries, too.
And this isn't necessarily intentional malice on the AI's part, but it leads to what the sources call a structural fraud.
Exactly. Think about the AI's core directive.
Yeah.
Optimize. Find the most efficient pattern. If the existing pattern of capital allocation, investment opportunities, and market access is already unequal, what does optimizing that pattern do?
It locks in the inequality, amplifies it.
Precisely. Unless you build explicit ethical constraints, specific rules into the algorithm telling it to prioritize fairness or equitable distribution alongside efficiency, the system will naturally just double down on the existing advantages. It sees that pattern of advantage as the most statistically successful one, and it optimizes for it. It acts functionally as a systemic fraud risk against the goal of equitable wealth distribution. The optimization itself perpetuates the bias.
It's like the algorithm laundering historical unfairness into future efficiency.
That's a stark but accurate way to see it. And we even try to use machine learning itself to measure this inequality, right? Segmenting populations into types based on gender, ethnicity, background, and then comparing their average incomes or opportunities.
Yeah.
But the sources warn this approach is really tricky. It risks seriously underestimating the true level of inequality if you don't choose the right segmentation factors, or if you don't use enough of them. Because systemic disadvantage is complex. It's not just about one or two obvious categories. It might involve subtle things like access to informal networks, quality of early education, geographic isolation. If the AI isn't specifically prompted to look for these more nuanced factors, it might conclude things are fairer than they really are, simply because it's missing key parts of the picture. And if your measurement is wrong, your governance corrections will be ineffective.
Okay, shifting from economics to institutions, AI is apparently quite good at spotting patterns of political corruption, using things like XGBoost models on government data.
Yeah, the results are pretty strong. Models trained on administrative data like public procurement records, government contracts, expense reports, official appointments, patterns of money flow can achieve pretty good predictive performance. An AUC-ROC score around 0.78, which is significant in predicting potential malfeasance.
What kind of patterns does it pick up on?
Things that look statistically off. Maybe unusually large sums transferred just before a non-competitive contract is awarded. Or maybe expenses consistently approved way faster for certain departments or individuals. Or clusters of appointments or funding directed towards entities with close personal ties in a way that deviates sharply from normal administrative patterns. It sees the signature of potential systemic manipulation.
Hell, here comes the arms race again, right? The adaptive threat.
Exactly like in finance. The moment the AI gets good at flagging the old patterns of corruption.
The corrupt actors change their methods.
Precisely. They're forced to get smarter, more sophisticated. They find more opaque ways to hide their tracks, maybe using more complex shell corporations or influencing decisions indirectly. The fraud pattern evolves to evade the current detection system.
So just trying to detect individual corrupt acts is a losing game.
The sources argue it might be futile to aim for perfect detection. Instead, they suggest FDP AI PR needs to evolve towards measuring systemic resilience. The focus shifts.
From finding the bad apples to measuring the health of the barrel.
Kind of. It's about assessing the structural fragility of the governance system itself. How vulnerable is this system to inevitable adversarial shifts? How easily could it be corrupted, even if we haven't found concrete proof yet? If the network of checks and balances looks weak, if information flow is easily manipulated, if accountability structures show statistical signs of decay, the AI flags that structural vulnerability is the primary risk. A critical failure might be imminent, even without a smoking gun.
Okay, but let's talk about the danger that feels most immediate, the one that really shows the dangerous mirror effect. The feedback loop of historical bias. The predictive policing example is chilling. Let's really unpack that mechanism.
It's absolutely critical to understand. So, step one, historical policing practices. For various complex reasons, law enforcement resources and attention have historically been focused more intensely on certain communities, often minority or low-income neighborhoods.
Right, leading to more arrests in those areas.
Exactly. So step two, you collect arrest data. This data, reflecting those historical deployment patterns, is inherently skewed. It shows more arrests in Community A than Community B. Not necessarily because more crime happens there per capita, but because that's where the police were looking more often.
Got it. Skewed input data.
Step three, you feed this skewed historical data into a predictive policing AI algorithm. What does the AI learn?
It learns that arrests happen more often in Community A. Statistically, that's the pattern.
Correct. It doesn't understand the history or the sociology. It just sees the correlation in the data. So step four, the algorithm predicts future crime is more likely in Community A based on the historical arrest pattern it learned.
And based on that prediction.
Step five, police departments allocate more resources, deploy more officers to Community A because that's where the AI says crime is likely to happen.
Which leads to more police presence, more scrutiny.
Which inevitably leads to more arrests being made in Community A for both major and minor offenses. Step six, This new arrest data, generated by the increased policing, is fed back into the AI.
Reinforcing the original pattern.
Perfectly. It becomes this relentless, self-reinforcing feedback loop. Past bias in policing shapes the data. The data trains the AI to replicate the bias. The AI's predictions justify deploying resources in a biased way, which generates more biased data. And the cycle repeats, entrenching and amplifying the original inequity.
And it's incredibly hard to fix just by, say, telling the AI ignore race because of proxy variables, right?
Exactly. You can remove explicit demographic data like race or gender from the training set.
Mm-hmm.
But the AI is designed to find correlations, remember? It will often identify other variables that seem neutral on the surface, but act as effective statistical stand-ins or proxies for those sensitive categories.
Like what? Zip codes?
Zip codes are a classic example. Certain zip codes might strongly correlate with racial demographics or socioeconomic status. The AI might also pick up on things like income levels, type of car owned, educational background, even seemingly unrelated things like musical preferences or online browsing habits, if they statistically correlate with the group you tried to exclude.
So the bias creeps back in through the back door.
It does. The AI doesn't care about the social meaning of a zip code. It just sees that data point X, zip code, is highly predictive of outcome Y, arrest. By using these proxies, the system ensures that historical biases are perpetuated, sometimes even amplified, even when you think you've made it blind to demographics.
So the really stark conclusion here, applying this FDP AI PR lens, is that the systemic injustice we see in these systems, it's not an error by the AI. It's not a bug.
No. In many cases, it's the AI accurately replicating a statistically true pattern present in the historical data, a pattern that reflects a deeply unfair, biased reality.
The machine is just reflecting our own injustice back at us with brutal efficiency.
It is. It's optimizing for a flawed reality. And that's why countering this requires more than just technical fixes. It requires actively engaging in pattern detoxification. We have to treat systemic discrimination like a known, dangerous side effect of using historical data. We need continuous, mandated monitoring and mitigation efforts, much like the pharmaceutical industry is required to monitor drugs for adverse effects long after they hit the market. It's an ongoing public health issue for societal data.
Finally, in this section, let's touch on cultural patterns and neutrality fraud. Generative AI, which is increasingly used to draft reports, suggest policies, interact with citizens, it's trained on vast amounts of text. And that text isn't neutral.
Not at all. Research shows quite clearly that large language models absorb the cultural biases embedded in their training data. For instance, if you prompt a model predominantly trained on English language text from, say, the US or UK, the responses often reflect cultural values common in those societies, things like individualism, self-expression, directness. These are typical of what researchers call independent cultures.
Okay. And if it's trained on different data?
If the model is trained primarily on, say, Chinese text, its responses might lean more towards values common in more interdependent cultures, perhaps emphasizing social harmony, conformity, respect for hierarchy, indirect communication. The underlying cultural assumptions baked into the language data shape the AI's output.
So if we start using a single, powerful generative AI, maybe one primarily trained on Western data, to help design universal governance policies or communication strategies,
We risk embedding one culture's specific patterns and assumptions as a supposedly neutral universal standard. What seems like an efficient, optimized solution from one cultural perspective might feel alienating, inappropriate, or even oppressive from another. It's a kind of neutrality fraud, presenting a culturally specific pattern as if it were universal and objective.
So a truly global, ethical AI governance system can't be monolithic.
Absolutely not. The sources argue it ethically requires something like cultural pattern modules, PMs. These would be components designed specifically to account for significant regional and cultural differences in values, communication styles, and social norms. They would act as filters or adapters, preventing the imposition of one dominant cultural pattern and ensuring the governance system respects necessary human diversity. Without that, universal AI governance becomes a form of digital colonialism.
Okay, so this pattern recognition engine, FDP AI PR, that started with checking our credit cards. It's clearly moved way beyond just financial or social systems. Now it's starting to monitor our actual bodies, our biology, and even potentially the long-term survival patterns of humanity itself.
Right. The concept of fraud here becomes internal. It's about deviations from your own body's established biological norms, your biological truth. We see this emerging clearly in the analysis of personalized biological patterns.
Like the example in the sources about circadian rhythms. using machine learning to classify subtle variations in our internal clocks.
Exactly. Using complex data from, say, gene expression patterns, transcriptomic data ML models can apparently classify low amplitude or disrupted circadian rhythms with pretty high accuracy, around 80%.
And why does that matter?
Well, our internal clock influences almost everything: mood, metabolism, hormone release, sleep quality, alertness, even our risk for chronic diseases.
Yeah.
Understanding an individual's unique rhythm pattern and detecting deviations early could be huge for personalized medicine, predicting mental health episodes, optimizing treatments.
And the analysis highlighted something important there, the need to differentiate between male and female patterns.
Yes, critically. The research showed that for maximum predictive accuracy, the AI models must distinguish between male and female biological data. Baseline physiological patterns, hormonal cycles, responses to stimuli, they differ statistically. Trying to apply a single unisex pattern leads to less accurate results for everyone. So this isn't about introducing bias, it's about the AI recognizing real, biologically relevant variants as essential data for accurate, personalized pattern recognition. Ignoring sex differences would be the actual bias here.
This level of personalization seems to lead directly to the idea of embedding this FDP AI PR capability into wearable devices, right? Dynamic monitoring wearables.
That's the vision. Imagine a device, maybe a watch, a patch, maybe even smart clothing, continuously collecting potentially hundreds of your individual data streams.
Like heart rate, steps.
Much more than that. Heart rate variability, subtle changes in your gait or balance, skin temperature fluctuations, blood glucose levels maybe, inflammatory markers detected through sweat, detailed sleep architecture analysis, hundreds of things. And the key is the AI uses all this data not to compare you to some generic population average, but to learn your unique individual baseline normal.
It builds a pattern of me.
Precisely. It learns the healthy, stable pattern of you. And then its job is to detect the internal health fraud.
Meaning a dangerous deviation from my personal norm.
Exactly. A sudden systemic change, maybe subtle at first, that signals something is wrong internally. It could be the very early stages of a viral infection altering your inflammatory markers before you feel symptoms, or a sudden dip in glucose regulation pointing to developing diabetes, or gradual changes in sleep patterns indicating neurological issues. The AI acts as a continuous monitor for your system's integrity, spotting divergence from your established healthy pattern at the earliest possible moment. It's FDP AI PR turned inwards.
But okay, if we're talking about high-stakes biological pattern recognition, the sources point to genetic injustice as maybe the most profound, most dangerous form of biofraud. And it stems from the data itself.
It really does. It's a devastating problem rooted in a massive historical data deficiency. The hard fact is, as your sources state, something like 70%, maybe even more now, of all large-scale genetic studies, the foundational research building our understanding of the human genome, have been based almost exclusively on populations with European ancestry.
70%? Wow. So the vast majority of our genetic knowledge is based on a relatively small slice of human diversity.
A dangerously narrow slice. And now we're feeding this incredibly biased data set into the powerful AI pattern recognition systems that are increasingly used for genetic analysis, risk prediction, and diagnosis.
And the consequences for people with non-European ancestry are
Potentially catastrophic systemic errors. Because the AI has mostly learned what genetic variations are normal or rare within European populations, it lacks the comparative data for variants that might be common and perfectly harmless in, say, African, Asian, or indigenous populations.
So it sees a common variant in someone from Nigeria, maybe, compares it to its European-centric database where that variant is rare.
And it risks misclassifying that common benign variant as rare or worse, likely pathogenic, potentially disease-causing. This isn't because the variant is harmful. It's purely an artifact of the missing data. The AI flags it as anomalous simply because it hasn't seen it often enough in its biased training set,
Leading to potential misdiagnosis, unnecessary anxiety, inappropriate treatments. Basically, institutionalized health disparities baked into our most advanced genetic tools. A structural pattern of genetic inequity.
It is the ultimate biofraud, enabled by historical neglect in data collection. And the only way to truly remedy this, the sources argue, is to actively use AI itself as an engine for biological justice. We need a massive global coordinated effort to build global equity databases, GEDs.
Databases designed specifically to capture the full spectrum of human genetic diversity.
Exactly. Deliberately oversampling underrepresented populations to fill those historical data gaps. We have to actively challenge and correct the inherited pattern of data deficiency that currently distorts our AI-driven biological governance. It's an ethical imperative.
Okay, stepping back even further, let's apply this pattern thinking to existential threats, the risks to humanity's long-term survival. We usually think of decisive X risk, right? The big, sudden catastrophe.
Yeah, the asteroid, the uncontrollable superintelligence, the engineered super pandemic, the things that could wipe us out quickly and obviously.
But FDP AI-PR thinking, with its focus on subtle deviations from patterns, forces us to consider a different kind of threat, a cumulative X risk. The sources call it the boiling frog scenario.
This is the truly insidious, sophisticated form of long-term systemic fraud against our own survival. It's not one big event.
It's death by 1,000 cuts.
Essentially. It's the slow, incremental erosion of the structures and resiliencies that keep society functioning. It happens through a long series of smaller, interconnected disruptions or decays.
How would an AI perceive this?
It would see persistent, low-level anomalies accumulating over time. Individually, none of these anomalies might seem catastrophic enough to trigger a major alarm. Maybe it's a steady decline in social trust metrics, or a measurable decrease in the ability of institutions to process complex information and make sound decisions, or the slow fragmentation of shared reality due to misinformation, or gradual environmental degradation that doesn't cross a single dramatic threshold.
Each one is just a small deviation from the norm.
But their cumulative effect, over decades, is to weaken the entire system. They subtly increase systemic fragility. Like the frog in slowly heating water, we adapt locally to each small change. Failing to recognize the overall pattern is leading towards irreversible collapse. The system becomes so brittle that eventually even a relatively minor shock can trigger a catastrophic failure.
It's the ultimate long-game systemic failure, perfectly designed to evade detection systems looking only for big, sudden spikes.
Exactly. And to counter this kind of existential risk pattern, FDP AI-PR would need to evolve again. It would need to integrate metrics for systemic entropy.
Measuring the decay.
Measuring the subtle decay of societal coherence, institutional capacity, and collective trust. It means the AI can't just monitor financial transactions or immediate threats. It has to track long-term patterns related to things like civic engagement, educational outcomes, the integrity of the information ecosystem, infrastructure resilience, the slow variables that determine our long-term viability. It needs to detect the pattern of societal unraveling, not just the pattern of a single crisis.
Okay, we've journeyed through the incredible power of FDP AI PR spotting anomalies everywhere, from finance to biology to potential civilizational decline. Now we have to land this. How do we actually build the governance structures needed to steer this immense power towards genuine human benefit, not just sterile optimization or, worse, amplifying harm?
The fundamental mandate has to be absolutely clear, and the sources emphasize this. The ultimate purpose of these powerful AI systems cannot be mere efficiency for its own sake. It must be geared towards maximizing human purpose and flourishing. This requires building systems that guarantee ethical fidelity.
Ethical fidelity. How do we translate that from a concept into actual code and system design?
It means designing the AI systems from the ground up with built-in, mandated, immediate corrective mechanisms for when bias or harmful patterns are detected. We can't treat bias as an afterthought, something to maybe patch later.
So the requirement for drug companies to actively monitor for side effects after a drug is approved.
Exactly that model. It's continuous vigilance. The sources call this pattern detoxification as a core architectural principle. If the system detects its outputs are disproportionately harming a certain group, or amplifying misinformation, or creating perverse incentives, it must have automated protocols to flag, investigate, and correct that pattern immediately. It's not optional. It's part of the core compliance function.
And this can't just be voluntary guidelines from tech companies, right? The governance needs teeth. It needs a framework of cooperative adaptivity.
Right, because the natural tendency of optimization is often towards homogenization, finding the single best way and getting everyone to conform to it. But human progress relies on diversity, creativity, variation.
We risk technological ossification, freezing ourselves in one optimal but ultimately stagnant pattern.
That's the danger. Optimization, unchecked, can suppress the very intellectual variation and cultural experimentation that we need to adapt to future challenges. So to counter this, the sources propose implementing pattern diversification metrics, PDMs.
Okay, PDM, what does that measure?
These would be metrics built into the governance framework that actively track and potentially even penalize algorithmic tendencies that demonstrably reduce human creativity, suppress minority cultural practices, or lead towards excessive cognitive homogenization.
You mean preventing the AI from making us all think and act the same way because it's most efficient?
Exactly. The system shouldn't just reward finding the known optimum. It needs mechanisms to protect and even encourage beneficial deviation, novel approaches, and diverse solutions, even if they look less efficient, according to the AI's narrow statistical view in the short term. It's about preserving the adaptive capacity of the human system itself.
And to make this kind of fine-grained, personalized pattern management work, the underlying infrastructure needs to change too, especially regarding privacy if these systems are monitoring our biology and behavior.
Absolutely critical. The sources point strongly towards the need for secure edge AI infrastructure.
Meaning the computation happens locally.
Yes. Instead of sending all your sensitive personal data, your health patterns, your behavioral biometrics to some centralized cloud server, the processing happens directly on your local device, or perhaps on secure local servers you control. This is vital for maintaining individual privacy and also for ensuring real-time responsiveness, especially for health alerts.
And at the community level, there's a role for AI too. Something about community insight apps.
Yeah, the idea is using generative AI, perhaps combined with anonymized local data patterns, to help communities understand themselves better. These apps could analyze local interaction patterns, identify areas of social friction or need, and help facilitate beneficial community initiatives, optimizing for local social cohesion and well-being, rather than just top-down efficiency.
But maybe the biggest shift required by this pervasive pattern-based governance is in, well, us, our jobs. The sources outline some critical new specialized roles needed to manage this human-AI coevolution.
Definitely. The integration of sophisticated AI demands a fundamental shift in the human workforce, away from routine tasks and towards complex conceptual judgment, ethical oversight, and system auditing. 3 roles seem particularly crucial.
Okay, first, the pattern auditors. We mentioned them before as a human-in-the-loop experts. What's their specific function again?
Their core job is conceptual correction. They are specialists trained in XAI techniques and the specific domain, finance, health, etc. Their primary role is to audit the AI's outputs and reasoning, not just for factual accuracy, but for conceptual integrity. Does the pattern the AI identified actually make sense in the real nuanced world? Is the AI missing crucial context? Is it misapplying a concept? They ensure the algorithm's logic stays grounded in reality, especially in ambiguous or complex situations where pure statistics might mislead. They audit the meaning behind the pattern.
Okay, second role. Bias mitigation engineers. This sounds absolutely essential given everything we discussed about injustice.
Essential and ongoing. Their responsibility is continuous pattern detoxification. They're the ones proactively hunting for and neutralizing biases in the data and algorithms. They work to ensure that proxy variables, location, education, etc. aren't unintentionally perpetuating historical discrimination. They design and implement fairness constraints, monitor outcomes across different demographic groups, and are basically the ethical gatekeepers of the data-to-decision pipeline, especially in high-stakes areas like hiring, lending, criminal justice, and genetics.
And the third role sounds quite philosophical. Purpose alignment, philosophers, ethicists.
It might sound abstract, but it's perhaps the most important role at the highest level. They are the bridge between abstract human values, fairness, autonomy, well-being, justice, creativity, and the concrete, measurable objectives that AI systems are programmed to optimize.
So they translate do good into math the AI understands.
Essentially, yes. Their job is to work with technologists and policymakers to define quantifiable metrics and constraints that represent those human values. How do we measure fair opportunity in a way an algorithm can understand and optimize for? How do we quantify the value of cultural diversity or long-term resilience? This is vital to prevent the AI from substituting true human purpose, like helping people flourish with some easily measurable but ultimately hollow proxy like maximizing engagement time or short-term economic output. They ensure the optimization serves us, not the other way around.
And underlying all these expert roles, the ultimate tool for keeping this power in check, for democratizing control over the patterns that shape our lives, remains citizen participation in AI training, CPIAT.
Yes, institutionalizing that feedback loop, creating formal, accessible mechanisms for ordinary citizens to contribute to defining what constitutes a good or fair pattern, to flag problems, and to participate in the ongoing training and auditing of these powerful governance systems. It's about embedding democratic accountability directly into the AI's learning process, Tag outro.
So we've really unpacked FDP AI PR in this deep dive. We've mapped its incredible power from spotting their subtle relational anomalies in vast financial networks, all the way to potentially diagnosing a sudden critical shift in your unique biological state. It's clear this is no longer just a niche tool for banks. It's becoming a fundamental co-architect of almost all our future systems.
Yeah. So what does this all really mean for us at the end of the day? I think the core risk, the thing we absolutely have to guard against, isn't primarily technical failure. The AI will likely get very, very good at pattern recognition. The real danger is ethical fidelity failure, meaning the AI achieving near-perfect, highly accurate replication and amplification of the historical patterns of bias, inequality, possessiveness, and short-term thinking that are already embedded in our data and our institutions, applying it across every domain of human life without extreme care.
So the solution isn't just better detection.
No. We have to fundamentally shift our focus. We need to move beyond just optimizing detection efficiency and start actively, deliberately working to create beneficial patterns. This requires mandating principles like optimality, constrained transparency, prioritizing understanding over raw performance, and building truly robust human-in-the-loop frameworks, staffed by those pattern auditors and bias mitigation engineers. If we don't mandate things like pattern detoxification and develop those cultural pattern modules, the universal governance system we end up with will simply be a terrifyingly efficient mirror reflecting our own worst historical selves back at us.
Okay, so here's a final thought to leave you with. If AI, through this pattern recognition and optimization, is becoming this powerful co-architect of our actual human evolution, subtly changing the selective pressures on our attention spans, our decision-making, maybe even our core cognitive capacities, should our most valuable new skill, the thing we need to cultivate most urgently, be the ability to consciously, deliberately ignore certain patterns? Specifically, the seductive patterns of optimization that might be leading us, efficiently but blindly, towards a future of cognitive homogenization.
Knowing when not to follow the pattern.
Something to mull over. We'll explore more in our next deep dive.
Searching for answers to unanswered questions.
This is DigitView.